Welcome, this is Professor Ridge, and today's lesson 6.3, Logarithmic Functions. And our first learning objective, convert from logarithmic to exponential form. Okay, so first I want to talk about exponential functions and their relationship to logarithmic form. So if we had this function and we did some xy values, 0 to the 0 is 1, right? And then 2 to the first is 2. And then 2 squared is -2, -1. 2 to the -1 is 1/2. And then -2 to the -2 is 1/4. Okay, and now we want to talk about the inverse. So if we go back and look at inverses, so if we have f of x is equal to 2 the x, and we want to do the inverse, find f inverse of x. So we're going to switch the f of x to y, and then 2 to the x, and then you're going to switch your x and y's. Oops. So we get x equals to the y. Oops, let me write that better. To the y. Now, then we have to solve for this y. Well, here's the problem. We don't have a function for this yet. So then we said, all right, let's define and this is where logarithms come from. We're going to say y is equal to log base, whatever the base is, 2 of x. So the relationship between these two equations here is the log function is equal to this one. These are equivalent, and it's the inverse of this exponential function. So basically, if we're switching the x and y, we're going to switch this. So it'll be 1, 0, 2, 1. Let's see. Why did I get -2 there? That should have been 4. 2 squared is 4. So then it'll be 4, 2. And then on the negatives, it'll be 1/2. We're switching the x and y's. So it'll be 1/2, -1. And then 1/4, -2. And then if I were to look at the graph, remember the graphs of inverses. So if we have this one, it would be the exponential. And then if we do, through y equals x, the inverse function is going to be, so let's see, 1, 0, 2, 1, 4, 2, and then 1/2, -1, 1/4, -2. So our inverse function, so this is y equals 2 to the x. This one is x equals 2 to the y, or y equals log base 2 of x. So that's the log function. We're saying, what is the exponent for 2 that gets you y? So if y is, did I do this right? X equals, oh yeah, I was saying that right. 2 to what power gets this number inside, right? So 2 to what power is the number inside? So if I want to know what's the log of, say, base 2 of 8, we're saying 2 to what power equals 8? Okay, so you should know 2 to the third is 8, so this is equal to 3. Okay, so now back to the text. We can express the relationship between logarithmic form and its corresponding exponential form as follows. So basically right here, this double-sided arrow, means equivalent to, or if and only if, depending on what we're talking about, right? Same thing. So this statement is true if and only if this statement's true. Or you can say this statement is equivalent to this statement, right? So this is how you convert between log form, this is the log form, and this is the exponential form. So notice that the y here, base to y is the exponent. So this is kind of like a mantra that I like to have my students say when they're doing a logarithm, or just a log. I'll go ahead and write logarithm is an exponent. Okay, so log equals exponent. A log equals an exponent. So when you're writing this, the log equals an exponent of the base. Okay? So b to the y is equal to x. B to the y equals x. So b to the y equals x. So you can think of it in this motion here. But I like you to just just keep in mind a logarithm equals exponent. So log equals exponent. So y is the exponent for the base, which is b. So b to the y is equal to x. Okay, you got to get that in your head. If you can get that straight, this won't be too difficult. This is probably the hardest thing for students, is you're just not familiar with this technique. Okay, here's the formal definition of logarithmic function. A logarithm base b of a positive number x satisfies the following definition. Now notice x has to be greater than 0. B is greater than 0. So x and b are positive, and b can't be 1. Okay, y equals log base b of x is equivalent to, right, that's the double-sided arrow, is equivalent to b to the y is equal to x. And again, remember, log equals exponent. Log equals exponent. Okay, so this is our base. Base. Here's our exponent. Exponent. And then x. So x is the input value here for the logarithm, and it's the output value for the exponential function, because remember, they're technically inverses. Okay, so the x is the input value of the log function, and then it's the answer over here, the output value for this exponential function. Okay, we read log base b of x as the logarithm with base b of x, or log base b of x. So log is short for logarithm. The logarithm y is the exponent to which b must be raised to get x. Okay, so y is basically b to what power to get x. Also, since logarithmic and exponential functions switch x and y values, the domain and range, so remember back to inverses, domain and range of exponential functions are interchanged for the logarithmic function. Therefore, the domain of a log function with base b is 0 to infinity, and the range of the log function with base b is all real numbers. Okay, let's look at example 1, converting from logarithmic form to exponential form. Write the following equations in exponential form. So let's see, we got log form, exponential form. Okay, what I like to do is just remind you, right? So again, our mantra is going to be a logarithm or a log equals an exponent. So remember that. So the equivalent form for log form, if we say y is equal to log base b of x, is the same thing as you start with the base, b log equals exponent, b to the y is equal to, and then the argument of logarithm or the input value, x. Right? These are equivalent forms. So A, if we do log base 6 of square root of 6 is equal to 1/2. The equivalent form, so remember you start with the base, so it's 6. Log equals exponent, right? So log equals exponent. This is my exponent for the base 6. 6 to the 1/2 power equals square root of 6, which you should know that from definition of rational exponents. Right? So square root is the same thing as 1/2 power. B, log base 3 of 9 equals 2. That's equivalent to, now remember, log equals exponent. So this is the exponent for the base. So 3 to the second equals 9. And you can see that's true. 3 squared is 9. Okay, our next learning objectives go the other direction. Convert from exponential to logarithmic form. All right, so example 2, converting from exponential form to log form. Write the following exponential equations in log form. So remember our mantra, a logarithm or a log equals an exponent. So you always want to kind of say that in your head there. And then just remember, so we're going to go from exponential. I don't know why it's not writing. Let me see here. Let me try that again. Exponential form to log form. Okay, so remember our base, the one we start out with. So y equals log base b of x. So remember we start with the base. B to what power? So b to the y is equal to x. Okay, so the first one. 2 to the third equals 8. So we're going to say, all right, so let me switch that around. I like to start with the base. I always start with the base. Just kind of get that in your head there. So log base b, so the base is b. Log equals exponent, so I leave space for the input value for logarithm. Log equals the exponent. Exponent in this case was y. And then the output value here becomes the input value for the logarithm. So we're going to do the same thing. We're going to start with log, identify the base. Base is 2. So the base goes down here as a subscript to the g. So log base 2, log equals exponent. So log equals exponent, exponent's 3, and that goes on the other side. And then the output value here is the input value for the logarithm. All right, let's try the next one. 5 squared equals 25. So that's equivalent to, we start with the log. Base, what's the base? 5. Log equals the exponent. So 5 squared equals 25. And that goes as the input. So the output value for the exponential form is the input value for the log form. All right. C. 10 to the negative 4 equals 1 over 10,000. That's equivalent to, start with the log. What's the base? The base is 10, so subscript 10 to the negative 4, so the exponent's negative 4. Log equals exponent, right? I want to get that in your head. Log equals exponent. And then the answer, 10 to the negative 4th, the output value, 1 over 10,000, is the input value here. I didn't leave myself enough room, but there you go. Okay, so hopefully just practice that. Hopefully that will sink in. Again, you want to keep repeating this to yourself. A logarithm is an exponent. Log equals an exponent. Okay, moving on to evaluating logarithms. Okay, so the technique then is given a logarithm of the form y equals log base b of x, evaluate it mentally. Rewrite the argument x as a power of b. Remember, b to the y is equal to x. Use previous knowledge of powers of b to identify y by asking to what exponent should b be raised in order to get x. Okay, so the way I do it, kind of like that, but again, remember I say I want you to kind of get in your head a log is an exponent. Okay, so again, if we think about this, we're saying 4 equals y, so log equals exponent. 4 to what power? 4 to the y equals 64. So we're saying what power of 4 of the base gets us 64. So if you think 4 to the first is 4, 4 squared is 16, 4 cubed is 64, so it must be 3. So y equals 3. So this is kind of what you think in your head. 4 to what power is 64? So, all right, let's try another one. Okay, evaluate y equals log base 3 of 1 over 27 without using a calculator. So again, remember, a log equals an exponent. Get this in your head. So we're saying 3 to what power? So log equals the exponent. What's the exponent of 3 that gets us 1 over 27? So whenever you have a reciprocal like this, you got to think of, see, reciprocal is 1 over, right? Think of that as, that's going to be a negative exponent. So if you do 3 to the negative 1, that's 1 over 3. 3 to the negative 2 is 1 over 9. 3 to the negative 3 is 1 over 27. Okay, so it's going to be negative 3. Again, we're just thinking about that. So y equals negative 3. And our next learning objective, use common logarithms. Use common logarithms. Okay, so first of all, what is a common logarithm? So a common logarithm is a logarithm with base 10. We can also write log base 10 of x simply as log of x. So this is our common log. The common logarithm of a positive number x satisfies the following definition. For x greater than 0, y equals log of x is equivalent to 10 to the y equals x. We read log x as the logarithm with base 10 of x, or log base 10 of x. Or a lot of people, we just say log of x, right? And so if we don't say the base, we're assuming that it's 10. The logarithm y is the exponent which 10 must be raised to get x. So the common log, y equals log of x, is equivalent to that up there, but it's also equivalent to y equals log base 10 of x. Right? This is the common log. Okay, example 5, finding the value of a common logarithm mentally. Evaluate y equals log of 1000 without using a calculator. So base 10 is nice because 10 to the 0 is 1, 10 to the 1 is 10, 10 squared is 100. So the power tells you, you always write, if it's 10 to some power, so like 10 to the third, you write the 1, and the power tells you the number of zeros. So 10 to the fourth is 4 zeros, so that's 10,000. 10 to the fifth, there would be 5 zeros, so that's 100,000. Now when you go in the negative direction, right, it's place value. You can also think of that one. So if I have 10 to the negative 1, it's going to be 1 over 10. So you have 1 0 there, or the same thing as 1 decimal place, right? So 10 to the negative 2 is 1 over 100, or 0.01, 2 decimal places. So you can think of it as the number of zeros with 1 over, 10, 100, 1,000, whatever. So 10 to the negative 3 would be 1 over 1,000, or 0.001. So that's 3 decimal places. Okay? So this is 1,000. So you got 1, 2, 3. So 10 to the 3 is 1,000, as we just discussed here. So the log base 10 of 1,000 is simply 3. So y equals 3. Example 6, finding the value of a common log using a calculator. Evaluate y equals log of 321 to 4 decimal places using a calculator. Okay, so we'll just use decimals. Most calculators, scientific calculators, you should have a button that says log. That's log, that's the common log, base 10. So one way we could do this is we could just say, all right, because we know it's the 10 is the base, and we want to figure out the power to get us 321. So 10 squared is 100, so that's too small. 10 cubes 1,000, that's too big, so it's going to be like the intermediate value theorem. We're going to go somewhere in between those two numbers. So 2.5, too small. 2.6 would be too big. So 2.55, right? And I want to go out to 4 decimal places. Okay, that's too big. So 252, too big. 251, too small. So now I can go out 1 more decimal place, and I can keep doing this game. Okay, that's too big. Too small. Too big. So on, right? I can keep doing this until, oh wait, that's too big. So 2505. Too small. Too small. Too small, so I got to go out another place. Too big. Oh no, wait, 9 was too big. So 8. 1, too big. Too small, so 6, 5, right? And you see I'm getting close. So 5, 6. So it's between 5, 6. 6, 5 and 6, 6. So 6, 5, and I have to go out 1 more place. Okay, that's too big. So if I round it to 4 decimal places, it'll be 2.5065. That takes way too long, right? So the idea is we have this the inverse function, which we just talked about being logarithm. So if I do log, it's right here. You can just type in log for this as well. Log of, we wanted 321, 2.5065, right? See what I said? 5065 to 4 places. So basically it's as simple as that. You just get a calculator. Now, depending on your calculator, some calculators you're going to hit 321 and then the function button, the log. And some calculators you're going to hit log first and then type in the number and then hit enter. So just make sure you can use your calculator. So y equals, what was it? 2.5065 to 4 places. So we should do the squiggly equals, the about, approximate. Okay, example 7, rewriting and solving a real world exponential model. The amount of energy released from one earthquake was 500 times greater than the amount of energy released from another. The equation 10 to the x equals 500 represents this situation, where x is the difference in magnitude on the Richter scale. To the nearest thousandth, what was the difference in magnitudes? So we're going to say we want to solve this for x, right? So 10 to the x equals 500. So remember, log equals an exponent. So we're saying log base 10 equals the exponent, and then the output becomes our input. So we're just going to type this in our calculator. So x is going to be about, so where's my Desmos? We're going to type this in. Again, you can just hit, let's see here, log, and it was log base 10, which is the common log, 500, and that equals 2.69. How many places do we want? 3 decimal places. 2.699. 2.699. Okay, so the magnitude, so if the base one was, say, a 5 on the Richter scale, this one would be a 7.699, right? Because it's this much bigger, 500 times greater than the other earthquake. Okay, on to the last learning objective, using natural logarithms. Definition of natural logarithm. A natural logarithm is a logarithm with base e. So the base is that Euler's number, 2.718, about 2.718. So we write log base e of x simply as ln, that's a L, ln of x, right? Natural log of x. So the natural logarithm of a positive number x satisfies the following definition. For x greater than 0, y equals the natural log of x, and that's equivalent to e to what power? E to the y equals x. Okay, we read ln of x as the logarithm with base e, or simply the natural log of x, or the natural logarithm of x. The logarithm y is the exponent to which e must be raised to get x. Since the functions y equals e to the x and y equals ln of x are inverse functions, the natural log of e to the x equals x for all x, and e to the ln of x is equal to x. So this is a big idea for solving a lot of problems we're going to do later on. If you take e to the ln, so if those bases match, they're inverse functions, these cancel each other out and you're left with x. So if I had e to the ln of 5, the answer is just 5. Okay? So you can see if I did on Desmos, if I did, let's see, you can just type in e for the natural log, e, and then power, and then ln of, say, 5, you see you get 5. So these are inverse functions. And then also, if I did ln, again, you could just type ln, type ln of e to the power, say, 7, you get 7. See, those cancel each other. So e to the ln of whatever number you put in is going to give you that same number, and ln of e to whatever number is going to give you the same number, because ln and e are ln and e, the x, are inverses of each other, so they cancel each other out. Okay, so let's try natural log using a calculator. Evaluate y equals ln 500 to 4 decimal places. So again, just on your calculator, you should have a button, if it's scientific, that says ln. If you don't, you can use Desmos, but on the test, the final exam, you'll have to use a calculator that you can't use your cell phone either. So make sure you have a calculator that can do that. I usually have a few extra with me if you don't want to go out and buy one. All right, so let's try this. So we're going to do ln of 500. And it's 6 point, how many places? 4. 2146. So y equals 6.2146. So we're saying e to the 6.2146 is about 500, right? We can check that. So e to the 6, power 6.2146. It's about 500 because we rounded it. If I want exactly 500, I got to go out a few more places. Well, technically, I have to go out an infinite number of places. Okay, so that's it. The answer is y equals 6.2146, or about. Again, I should use my squigglies. About. And I believe that brings us to the end of the lesson. Yes, it does. Okay, so again, practice, practice, practice. Go to the end of the section 6.3 to the exercises and do as many of the odds as you can, preferably all of them, and then do some of the evens if you have time. All right, talk to you later. Have a great day.